morning, everyone. Welcome to another episode of Sound Talk Show. Today is August 28th, and 12 o'clock p.m. California time, Wednesday. Good morning, Bartholomew. Good morning, Ztron Crazy. And today, okay, what is the topic? Type a topic, guys. Type it. I'm thinking, let's continue with yesterday's Python plus Emacs. So I'm going to show Python, basics Python, and then I'm going to show how to do that in Emacs Lisp. But unlike yesterday, I feel yesterday went bad. Yesterday then I start to ramble about things, and I don't know anything about Julia number 10. Yeah, I don't code Julia. It's something I like to learn, but I got other things on my plate. So I was thinking, so yesterday I did video, Python, teaching Emacs Lisp via Python constructs. But that we went off on a tangent, like every time I feel like, every time, when I'm trying to, when I'm trying to do a, focused presentation, there's pressure, and usually it's not so fun. And but I'm getting better. So maybe we can continue that today if there are people like to see that, and or other topics. So Bartholomew says, "You Oxar, you know everything programming language by looking at it." No, I don't. It's hard to learn programming languages. Actually, yes, it's hard to learn. Like people. Good morning, panels. People like to say, it's Julia, shut up. I don't know anything about Julia. All I know is that Julia is a language, a programming language that's very fast as Golang, as fast as, in some cases, faster than C, faster than Golang. Yeah, it is actually faster than Golang. And Julia is designed for mathematical scientific programming. So in the same class as Fortran. So math languages: Fortran, Mathematica, Julia, APL, MATLAB. Okay, that MATLAB is pretty lousy, and MATLAB, and these are mathematical languages. Good morning, Seamus. Seamus, we don't have a topic yet, so type a topic. Okay. I don't know Julia, so I cannot teach Julia. All I know is that Julia is a math language. But there is something interesting. Let me show you. So let's go to xali.info. And let's go to my website, xali.info, and let's go to programming blog. Let's move the window here. And then check. Good. And then we go to, oh yeah, math languages. So we go to on Lisp, no. Syntax soup, no. Semantic noodle, yes. Semantic noodle. Math. So search for math. This article, a class of computer languages, math languages. Now most programmers, they code C, C++, Java, C Sharp, Perl, Python, Ruby, including Haskell and Clojure and Lisp, Scheme, Racket, Scheme, and Rust. All those are not math languages. Okay, so these are industrial languages, and vast majority of industrial programmers, they have no idea, like they've never seen a single line of math oriented programming languages. So every day, particularly C and C++, those type of people, uh, C and C++, those they like to talk about compilers and the Unix philosophy group. They like to talk about their mouth every day is like, oh, parsers, compilers, int, float, memory address, array, references. These people, you have no idea. So when you discuss, when often you have debates about programming languages, their brain lives in this well. They because in their life, even if they have programmed 20 years, 30 years experience, people like to brag, oh, I programmed for 40 years, then this and that. But they live in this well. They have never done in their life scientific programming. They have never seen math oriented languages. Why? Because in programming industry, that's not what you do. The math oriented languages, scientific programming, well, they are part of industry. For example, visualization of 3D objects, CAD. CAD. You have those. Well, even CAD. You don't program CAD in math-oriented languages, but within CAD, typically there are scripting languages. That's when that for that you do use math-oriented languages. Okay. Anyway, so I was saying, so scientific programming, okay, using math-oriented languages. Who use them? NASA, for example. You do research. You shoot rocket to Mars. You need a lot of research. I mean, it's not just usually when programming talking about that NASA, they talking about the code that sends people to the space. It could be C. Actually, Lisp has been used, common Lisp. But basically, programmers are thinking, whatever the console, the in the shuttle, whatever. Those are not, those are before you do that, you have to do lots of like whole tons, 10 millions times more code in researching, in modeling the trajectory, modeling or that solving 1,000,000 differential equations, solving a billion matrices. That how you do that? You do that using math-oriented languages. Okay, so I was saying Mathematica, APL, Fortran, MATLAB, uh, Julia, and the latest one is Julia. That's good. And R for statistics. Okay, so these are math-oriented languages. Vast majority of programmers, they have never do them in one line of code. Never done scientific programming. So they live in this well. This is C++, Java, Perl, Ruby, Perl, Ruby, Python. These people, including Lisp and Haskell coders. Haskell is special because they think, Haskell people like to think, oh, we are math. We are math. No, the Haskell language, their design, everything is industrial programming. They're not nothing. For example, one easy way. Let me tell you some easy ways to tell whether a language is industrial, is math oriented language. Okay, guys, comment. Okay, so let me give you two simple way, litmus test, simple way to, if there's a language, if there's a new language, there are a few simple ways to tell if it's math oriented language. One, one, does its array or a list, okay, does the index start with 1 or 0? Okay, if it start with 0, that's not math language. Okay, that's crap. That's like C Sharp, Java, this Perl, Python, whole bunch of crap, including Lisp and Haskell. Idiots. So if the array index starts with 1, then it's likely that's a math-oriented language. 2, another test. Okay, does the language has built-in functions to multiply matrix? Okay, yes, then it's math language. No, then it's not. Okay, so all these languages, Julia, APL, Mathematica, Fortran. Yeah, well, Fortran is mostly a number cruncher, but yeah, I suppose including Fortran. So yeah, so that's about math-oriented languages and scientific programming. So who does scientific programming? The NASA researchers, the researchers, basically typically scientists in research labs all over, may it be typically have anything heavily related to physics or engineering around physics, such as nuclear reactor, nuclear facility, hydro dams, the water dams. You need research. You need to have you need solve a billion differential equations. That's math. That's scientific programming. Okay. Now it is also true. Typically, these scientists, okay, they have PhD in physics, in engineering, in math, okay, but typically, they are not what you might say professional programmers because they do research. They use this language to research, but they are not. They are different from industrial programmers. We could say it's true that they don't really know. Um, they don't really know programming that well. I mean, that maybe that you could put it that way because they don't really study algorithms. Okay, that's not what they study. They don't know about well, they know some aspect, but they don't, like, unlike programmers, they don't study 10 ways to sort. They don't study that. They don't study compilers. They have no idea what compilers do. All this math-oriented language, you don't compile. Okay, you type the code, you get answers, and they don't know. So they don't know operating systems. They just use, they so that's why it's different. So these are scientists, scientific programming. They do scientific programming. And by the way, it's not like, easy. It's not like using a calculator, to solve equations. It's involved. It just and of course, some of them know a lot of both, and also it's true that some industrial programmers, they have experience with scientific programming, such as myself. I do scientific programming most of, well, half of my life, and the other half is, Perl and, this industrial programming. So that's math-oriented languages. Okay. Now I've given two tests to see what's the difference of math languages. So array index, does it start with 1? Does the language has built-in matrix multiplication, for example, matrix and vector, or matrices multiplication? Another simple way, characteristics of scientific math-oriented languages is that um, typically the language is designed. Okay, here there's a word, applicative programming. That's almost synonymous with scientific programming. It's an application, so you could say it's like a scripting language, applicative programming. Okay, so in this kind of languages, you never ever have the concept of references. Okay, references is the number one crap in programming languages. Reference. Why is there? Because these C programmers, C Unix philosophy, these idiots, they want it to be fast. Therefore, they created references, which is a side effect of computer engineering. You don't, in any real problem, you don't actually want references or int float, this kind of thing. But it almost, for in practice, they become reality. They are required because you need to get it to run fast. Otherwise, it's 10 times slower. That's why. But in these math languages, all these math languages, they are higher level. You don't have the concept of references. Okay, no references, no int flow thing, no such thing, and array starts with 1. Okay, that's what mathematicians want. The programmer idiots, they you ask any programmers, they always say, oh, I prefer 0. And and also their reason, they think their reason about history is also wrong. They think that, oh, because memory start with 0, therefore, or some reference pointer arithmetic, something like that. It's actually incorrect, wrong, because for example, people have done research, and I wrote an article about it. There's a research like, what's the origin of array? Languages where array index begin with 0. What is origin? So this guy have looked into in detail, and he contact some of the original designers of the B language, which comes before C, the B language, and so what's the conclusion? So why did array start with 0? Because some IBM executive, you know, he needs to run he needs to use the mainframe to compute his Yacht races. Therefore, it ends up, array start with 0, something like that. You can read it here. Uh, and oh my God, Python, the Guido has, have a say on that, Guido. Okay, so what is today's topic? What is today's topic? So that's about math-oriented languages. Okay, let me tell you. So, and that article is about array index. So math-oriented language. Let's see. So I was like, this is a Twitter post. Extravaganza. This is Twitter post turned into a essay. So each line is only 140 or each line is 140 characters. A Twitter turned essay. So a class of computer languages, math-oriented languages. Okay. So post comments, guys. Post comments. So Golan, Sima says Golan. How long we've been talking? 17 minutes. Okay. Golan. Okay. Well, what to talk? Okay. So let's close that. Let's go to talk show page, and so today's here. Let's put it there. Show in browser. So here is today. Wait, what is this? Yeah, today, August 28th. So comments. So let's see. Let me read the comments then. Mathematica, you are pro. Okay, actually, it's good to mention, Julia. I'm working on a project where I need to accurately calculate pi, so I'll give it a look. Yeah, you can try, Julia, or in Mathematica. Let me show you in let me tell you something about Mathematica. Suppose you want to compute pi to 1 million places. Okay, what do you do in Mathematica? Let me show you. N pi 1 million. Okay. Press enter. Then it comes out the result. Pi to 1 million decimal digits. That's Mathematica. Okay. So people say, oh, how many lines of Mathematica? This one line of Mathematica, how many lines is in C? 10,000 lines of in C. And we are not getting into solving equations like differential equations or systems of differential equations or matrices or stuff. It's all just like one line, integral and stuff, integral and derivatives. That's Mathematica, math-oriented. But Mathematica is a special case because Mathematica is also a what's called computer algebra system. Now, almost, computer algebra system can do what I just said, solving equations. But that does not. But not all math-oriented languages do that. For example, APL doesn't have that. Fortran, I don't think you have that. And also because Mathematica does symbolics, right now it's numerical. Pi to 10,000, 1 million places. That's numerical computation. Mathematica can do. Now, if you want to solve a differential equation, let's say a derivative, you can, by the way, you can type this in Mathematica. You can actually just go to Wolfram Alpha, on the web. You type this, it'll work. But this is too big. It won't do that. You can type, 100 or 10, it'll work. Pi to 100 decimal places. For example, if you want to do derivatives, you can type, x third power plus b times x to the second power. Let's say that with respect to x. Type that in Wolfram Alpha in Mathematica. It'll give you symbolic expression. Now, let's see if my calculus is. I still remember calculus. The answer would be 2 times x raised to 2 and plus x, I think. Okay, I don't remember calculus. Let's try Wolfram Alpha. Wolfram Alpha. Wolfram Alpha. Computational intelligence. Oh, that's their new marketing line. Computational intelligence. Let's try the pi to 1 million places. Show me. Assume n is a math function. Use unit instead. Input pi 1 million digits. No, there it is, the result. Okay, it cannot show all, of course. If you want to show all, you have to click open code. Let's say open code. I think they're gonna ask you to pay to use Wolfram Cloud or something. But anyway, that's pi to 1 million places. Let's try this. Okay, yeah, cloud, Wolfram Cloud. They're gonna what is it? Oh, oh, this is Mathematica. You can actually run Mathematica. Oh, they have a web version now. Let's see if we can actually do something here. Oh, they have a web version. Wow, experimental. Let's see. 3 plus 2 equals to what? Syntax is incomplete. What? This is wrong. Three, okay. I think their web is screwed up. It's something 3, enter. Shift enter. Oh, okay, shift enter. Let's see. 2 plus 3, shift enter. Okay, 5. Now let's do let's try the derivative then. Paste, shift enter. Okay, I got the syntax wrong. Let's see, derivative. This is Mathematica actually. This is like web version of Mathematica. I haven't coded for like over 10 years. So let me read the comments. Good morning, Nick. So Nick says, when XR picks up Julia, I will be propelled to the mainstream. Okay. It's open. So I'm waiting for the stream where you teach Julia. Yeah, that'll be something. Uh, no, it's not. Well, this is Jupiter copied Mathematica. You know, you see this Mathematica interface. This been there since 1980. 4. I think that's the year Mathematica began. 1984. Oh yeah, today there's a topic I like to talk about it. Since you guys don't have a topic, let's just go random then. Wolfram, Stefan Wolfram, this guy is truly amazing, and I tend to, he and me, we see things in same kind of point of view. So a lot of things he say, I agree. I mean that's also kind of my view of the world, the way I see things. But of course he's a genius. He's a certified genius, and he just wrote a blog today. Like almost every one of his blog, each one of his blog is like 5,000 words. Okay, it's not 1 minute reading. Each time he made a blog, he makes a blog every month or two. Okay, every time he write a blog, it's 5,000, 10,000 words with pictures and stuff. And and that's yeah, and each time you read it, you can just scan it quickly. It'll take you 10 minutes. But if you actually pay attention, it'll take you 20 minutes, 30 minutes to read the whole 5,000 words. But there's so much detail in depth, like so many you if you really actually want to understand or absorb the thing, it takes several hours to read them. Because and also not just not just what the content, but also the subject matter is typically like advanced computer programming or computer science or uh, cosmology, quantum mechanics, things like that. It's very advanced topic, so you can spend hours to dive into. And and today, 2 days ago, he just wrote this, and I read it. After I spent 1 hour first reading. Actually, I pay attention to details, and it's truly deep. Okay, so he's talking about a book from Alan Turing and a mysterious piece of paper. Okay, he unlike one thing interesting is that this article he posted on Twitter. You get 100 likes, maybe, actually 30, 50 likes, not many. But you look at what he says, compared to Hacker News, though everyone likes, 1,000, 2,000, or very popular. They are so extremely shallow. There's nothing like like people what people talk about on Hacker News. Oh, Lisp is not lambda calculus. Actually, recently, like 1 week ago, the Lisp phonetics idiots, they say, oh, Lisp is not lambda calculus, and whoa, everyone is talking about that. Whether is Lisp actually a lambda calculus or not? These idiots. Um, but you read this article, okay? Stefan Wolfram, he's talking about Alan Turing, and in this article, he visited, the Alan Turing's family because he's trying to find something out, okay? He visited Alan Turing, he visited several people, talked to them, and went to some, archive Alan Turing, and there's research. This is, nobody can write this. You have to have First of all, you have to have money, a lot of money, to enable you to go around, visit people, visit, the Alan Turing's teacher or something, Alan Turing's student. You have to visit them because they possess some of the items, books from Alan Turing. Alan Turing's writing, writing. You need to when you want, he's finding out lambda. In this article, he also talks about lambda calculus, common Y combinator, lambda calculus, formal logic. You can read it. It's very interesting. Okay, and this book is about quantum mechanics. By written by this Paul Dirac. You know, so this actually, so this is even more than Wikipedia. This is Wikipedia is, you can think of Wikipedia is like organized information from the web. You can kind of think of it as like the academic information on the web, then you organize it. That is kind of like Wikipedia. This is this is far beyond, because there's so much research. You don't get these books. These are copy 1930 book published in German, and Alan Turing owned it, and then gradually he got the book. Um, then there are notes inside the book. There are things like that, notes, and so he wanted to find out who wrote the notes, things like that. For example, this is you can see, there's a note in the book. So you have to do research, like who wrote the book, who owned the book. The book passed hands. Maybe did Alan Turing bought it, or was it from a used store? Things like that. When did he read the book? And who? There are several notes, and there's a bookmark. This is like 70 years old bookmark. 80 years, 90 years old bookmark. And the more notes, then there's these notes about this is lambda calculus and combinator. So these are the heart of theoretical computer science. You know, and when Lispers, the Lisp fanatic idiots on Hacker News or everywhere, when they talk about lambda calculus, their thing is Lisp a lambda calculus, or Haskell is based on lambda calculus. You should learn lambda calculus. The fucking idiots. Okay, so I was going to try the derivative. Let's see if we can actually do that. Let's see. Let's go to Wolfram. Let's finish. Yeah, let's finish that. Wolfram Alpha. Uh, Wolfram Alpha. So wait. What? Equation solver. What? Go back. Wolfram Alpha. So go to Wolfram Alpha. Shit. WolframAlpha.com. Oh, you have to. The top searcher is on the right side now. Yeah, that book is Principles of Quantum Mechanics. I suppose if you want to learn that subject, that's actually not the proper book, because it's 90, 70, 70, 80, 90 years old. It's taking a long time. What's going on? So anyway, so this article, this blog by Stefan Wolfram, you can read. It's very interesting, and you will also learn something about lambda calculus and combinators. Those are kind of the foundation of theoretical computer science. Remember, it's theoretical. Nothing. It's not nothing practical. It's like Turing machine. Okay, it's not. You cannot use them. Uh, let's see. Let's close that. New window. Paste. Enter. What's going on with Wolfram Alpha? Maybe because I'm already using it here, so it throttles or limits my access, something like that. But anyway, Wolfram Alpha is supposed to be this AI engine, but every time you want to search something, it's It's shit. You find nothing. What? Um, so you actually Google or whatever web search is better. But if you want to do math, or if you want, you want to find how many elements are there, things like that, very precise scientific things, then Wolfram Alpha is useful. So let me read the comments. So Julia, I'm into computer languages, so every so when you guys talk about it, that piques my interest, but it's really something I should not do because it's going to be just it's going to be it's a procrastination thing for me. I got other things more important for for me to survive. Yeah, then I'll study Julia. Then that's gonna just be like yak shaving. Uh, so is there a Linux program? Bartholomew says, is there a Linux program called Spigot? There is. Okay, there is a Linux program called Spigot, which calculates e pi and other as long as you keep the program running. Oh, okay. Uh, well, yeah. I mean, there is also. I know there's also a program that calculates pi in written in C by this C expert. The world's number one C expert. What's his name? Ballard something, a French guy. Anyone remember his name? He also wrote, the Linux video FFmpeg, the core library for FFmpeg, for processing video. Uh, Anyone remember the name? Paste it. The guy Ballard something, a French guy, and he is also a record. Okay, this Wolfram Alpha is not going to come up. This Ballard guy is also the record holder for a period of time for memorizing pi to some digits to a Fabrice Ballard. Yes, thank you, Nick. Yeah, he memorized pi to some thousands, 10,000 or 100,000 places. It takes several hours to recite them. So, and he also wrote, he's an Emacs user, but Emacs cannot store pi. When your buffer is large, Emacs crash, becomes super slow, unusable. So he created his own editor, kind of like he created his own editor so that it can store huge amount of digits for his Wolfram Alpha. Wait, I just entered derivative. Go. Unlock step by step. What? Oh, computing. Okay. Um, so yeah, the Fabrice Ballard. He's a C, the world's top C expert. He also he won one of the competition for obfuscated C code. I remember that because you can go to Wikipedia and you'll find all his stuff. Um, and recently, actually, this is interesting. So let's talk about that. Recently, he actually, so I this is my web blog, web dev blog, JavaScript. He he wrote a JavaScript compiler in a new JavaScript engine, JavaScript compiler called QuickJes. So you can. This is his website. So he's a genius programmer. He's a true master of programming in a traditional hacker type sense. The Unix people, the Unix philosophy people. All those people I flame all the time. Now, those type of people, he's the master. He is the number one master who talks about references in flow, those things all every day. And he is a master. He's the number one. Uh, yeah, I consider him kind of like almost like probably true. The world's within top 10 greatest programmer alive. So let's go to his web. He wrote this JavaScript engine, compiler, which and it is ES. Let's see, ES 2015 compatible, I think. Yeah, it even has ES 2020 support. So I mean, this is not just a random Joe. Typically in these hacker types people, random Joe, they'll say, "Oh, I wrote a JavaScript compiler," but that's just toy. His compiler is standard compliant. The spec compliant, meaning that you have tests to pass. You have to pass 69,000 tests. When you do that, you can, almost like anyone, you can write a compiler for JavaScript, okay? But if you want to be standard compliant, that's like 100 times more difficult. Literally 100 times more difficult. Not even mentioning speed. I mean, we're not talking about speed. Suppose your compiler can be 10 times slower, that's okay. But you want to be compliant with these, the spec, this industrial kind of, real JavaScript language. That's 100 times difficult. Because for example, if you try to compute int, arithmetics, the on the same machine, the decimal must match. I mean, so it's not just writing a compiler in theory. You actually, there's a lot of things. Anyway, that's my praise for this guy, this fabulous ballad, fabulous ballad creature. Yeah, so he's truly a genius. But again, like I said, he's in this hacker, for lack of words, hacker type of people. That's not my, that's a community I wallow in, but that's not my type. Okay, that I don't, I have no interest. I have no interest whatsoever in doing what he does. I have no interest. So what I'm interested in formal logic, okay, in proof systems, in Haskell kind of, in Haskell, language design, that kind of thing. But he is just diving into C and care for nothing else. Okay, that's that. So, hey, good morning, Daniel Langlos. So no comments today, I guess. No comments. That's boring. Boring day. Okay, so we talked about random chat about the this guy, and also about Wolfram, Stefan Wolfram. This fantastic article. Okay, go read it. Stefan Wolfram, fantastic article, and not, you see, he has written this blog, but he has written lots of other blogs in the past. You go read them. Each one, you really want to absorb what he says, takes hours, okay? And also, of course, you have to understand the subject matter. For example, this one, half of the content is about about lambda calculus, about combinator, about Turing machines, about cellular automata. So if you never studied that, you don't understand it. Of course, you don't. Half of it you would miss. Then you have to study. Then you have to take one course. You're gonna take one course in cellular automata, in theoretical computation, lambda calculus, formal logic, those kind of things. So this is just one of his blogs. He has other blogs about quantum physics. I don't understand. About lots of things, programming language design, and a new kind of science, of course. He sent me the book. Let me show you. Let me show you my book then. He sent it to me in 2004. But when he sent it to me, I already bought it back then. Back then I was working, I have money. Hold on. book. This is a door stopper, and this is also his book, new book, a few 4 years ago. Hold on a second. Check, check. Am I alive? Good morning, Daniel Langlois. How are you? So Daniel Langlois. So I have but apparently I stopped coding my. I stopped updating my software keys on GitHub. I feel bad about it. It's my project. I have to. I'm gonna get back to that. Uh, so let me check the comments real quick. Then let's talk about this book. This book, okay, Wolfram language. This is new book. This book teaches you about Wolfram language. The Mathematica. Um, did he sign it? No, I don't think he did. Okay. Anyway, he sent me this book like 3 years ago when it came out. I'm a master. I'm the world's top maths master of Mathematica back in 1990s. I don't need the book, but anyway. So this is a new kind of science published in I think 2002. Um, Very heavy. This. Let's see. So this is a pen. So heavy book, and it's actually repetitious. Every page he says I'm a genius. Every page. How many pages are there? Let's see. So including index. So if we do not include the 20 pages of index also, you have 1,197 pages. You can buy it. By the way, you can still buy it, but it's also online on his website. Just search for that name. I read this book actually. So I read this book when it came out, like in 2002 or so. And then I read it. In total, I read it almost like 3 times. And I like, Wolfram. Stefan Wolfram is a guy a lot of people do not like because he's a megalomaniac. Because he has to make sure everyone knows he's the greatest scientist in the human kingdom. And every page of this book, like almost literally every page, he has to say, he has to let you remember that he's the greatest. Like it's like all the others, yeah, Einstein. He doesn't even bother, to say I'm greater than Einstein because that's too low. Einstein or whatever is like in the footnote. Oh, by the way, Einstein did this. you know. So anyway, so he, so this book, yeah, I read it, and I have a complete, well, not complete. I have a, yeah, I can. We can talk about this book. What is it about, and some of my comments. A lot of people hate him. He doesn't get along with many. Great. Scientists, mathematicians or physicists. Because he's very arrogant, kind of. In a way, I would say, not necessarily. It's not necessarily true. Rather, I would say that because he does not follow, he does not conform. Typically people, especially academics in academia, in universities, you have this structure. You conform, then you climb the ladder. Okay, You have to conform to the rules. It means something you don't want to say, don't say it. Okay, then you climb the ladder, then you get tenure. You are a professor of cosmology, or professor of math or things. You have to do that. But he doesn't. Of course, he's and he can do it. He's capable, and he started his own company and stuff. So we can talk about that book. So, well, in order to talk about that book, let's go to my math blog. Okay, my math blog. Go to so I can find the link. So here is my blog about this book, Notes on New Kind of Science. Okay, and I wrote this in 2008, 2006, long ago. And so I try to kind of summarize what each chapter is about, because this book is he Stefan Wolfram, he does have a problem. This megalomaniac. That is actually true of him. He you know so first of all, this book is about cellular automata, which is a fascinating subject. Now, if you have not studied that, go study it. Just go study. There's a game called Game of Life. Okay, online everywhere you can see it. Go first of all. Go to Wikipedia. Game of Life. Let me show you that. Game of Life. I played Game of Life for 10 years in 1990s. Like for like 2 3 years. Almost every day. It's Game of Life. It's fascinating. Okay, so first of all, you go to Wikipedia, and you can read about it to begin with. Okay, if this is new to you, so you go to Wikipedia, read about it, then you can try some of the online implementation of that. Okay, there are fast ones. You when you Once you are familiar with it, you want to use those fast programs. Okay, so let me show you my stuff then. Well, yeah. So let me show you a new kind of science. Let's start to write what we were talking about today. So hold on a second. So okay, so there's so many things. Okay, first of all, open a new buffer, paste. Hold on a second. Comments. Okay, comments. So let's go to my talk page. Today's talk page. Oh yeah, here. So I want to summarize what I've talked about today. So kind of we can. So what is this? Okay, we don't need that. We don't need that. And what is this? Programming blog. Okay, programming blog. Oh, that article. This article we talked about that. That's Stefan Wolfram's article, blog. Make a list. Okay, and then we talked about those things. Derivative Mathematica. Okay, copy it, and Mathematica. Okay, those are Mathematica code. And what is this? Oh, the Fabrice Ballard guy. QuickJes. Okay, let's copy that. Close. Show in browser. Okay, so some of the things we talked about, and then yeah, then let's talk about Game of Life. Okay, so you should go study Game of Life. Hold on a second. You should go study Game of Life. Cellular automata. Automata. Okay, close that. cellular automata. Okay, game of life. Game of life is the most famous example of cellular automata. Um, so 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 yeah, if you have not seen this, this could be a topic we can show. It's truly amazing. It's fascinating. And okay, so let's see. Uh, Conway's Game of Life. Okay, this is invented by John Horton Conway, which is a very famous mathematician. In particular, his interest, the subject matter that he is interested in appeals to me a lot because he's kind of my type of mathematician. The things he study, I'm interested. Because in math there are so many branches. Some are just like programming. Some are interested in programming language design, like you guys interested in Julia, and so on, and other people are interested in Java. They just want to write programs. So John Horton Conway, he's very interesting. He's so anyway, learn read Game of Life. Okay, that's a fascinating thing. And automata, automata is part of theoretical computer science. Okay, but not not the core part though. Um, you can have universal machines in automata, like Turing machine. There's you can call it. There's a Turing machine in as cellular automata. But anyway, what's so so that's web dev. So so let's go back to what are we talking about? Conway is amazing. Yeah. So yeah. Uh, So let's see if oh it did. Okay, so Wolfram Alpha it actually gave the result for the derivative. So you see, um, equals to what? X times 2b plus 3x squared. X times 2b plus 3x squared. Did I get it right? X times 2b. Hmm. 2bx plus 3x. I got it wrong. Okay. 2bx, wait, that's not right. 2bx plus, okay, 2bx plus 3x squared. So 3x squared, oh yeah, I got it wrong. Yeah, 3x squared plus 2b plus 2bx. Yeah, okay, that's the answer. So anyway, that's Wolfram Alpha. You use math-oriented languages. Yeah. So we were talking about math-oriented languages and close that, close that, close that, close that, close that. Index. Okay, let's copy that. We explained index and math-oriented languages. Okay, so that's what. So what else? What else? You guys have two comments, or what kind of topics we're gonna talk about? New kind of science. So back. Oh yeah, that's his article. So Wolfram Alpha. Okay, 1 hour, 1 hour talk today. Anything else? If not, then I'm just going to go random then. Uh, HTML parsing in Emac Lisp. Uh, I like to write that, but so far I haven't done so. I really like to do that, But actually, I think to do that, you should use Golang. There's something we can show. Let's talk about that. Let me read the comments a little bit. So Nick says, new kind of science. A new kind of science. 10 kilograms of raw knowledge. It's all about cellular automata. So okay, let me explain the book a bit. Okay. Uh, by the way, so you can read my my website. When I'm done, go read my website. That's what I'm posting them for. Because that's my website. You support my website and share my website. Okay, post to your discussion, Twitters, wherever in your blog. That would be good for me. That's helping me. Or drop coins in my pocket. My PayPal and stuff. So anyway, this book, I have a kind of a summary of it, but I let's talk over it. So this book, there are two parts. This book you can divide it into two parts. Okay, the first, there are like 12 chapters, I think. Let's see, seven. Okay, seven, eight, 7 chapters plus notes. Okay, now the two parts of the book. The first 7 chapters are about all related to cellular automata. But the other half of the book, the notes part, like he's very strange guy. He's one of the kind of very unusual guy. So when he write a book, I'm getting on. Hold on a second. Let me find it. Let me show you what's going on. Okay. So this book is tremendous. I truly, really enjoyed it. I recommend you get it. But let me warn you, it's truly repetitive. So okay, so this here's two parts to the book. So 1/3 of the book is notes. This third, it's all about notes. So what are these notes? These notes are basically you can think of it as a overview of the history of math or computing. The overview of the whole human history. Okay, of computing, math, or physics. That's the last, the end part. This section of the book. Now the rest, the 2/3 of the book is about cellular automata. But actually, so that's chapter 1 to 12. Okay, there are actually 12 chapters. Chapter 1 to 12. I only cover 7. There's a reason though. Okay, so chapter 1 to 7 is all about cellular automata. There are so many different kinds. So what is a cellular automata? We can go explain it maybe in a moment. This is cellular automata. Okay, little things move, and also the cover of the picture. You have to see a clear picture of it. Okay, so let me show you then. Cellular automata. So yeah, let me show you. Okay, so there's quite several very interesting stuff. So let's show them. And by the way, the Go game can also be considered as a cellular automata, and which is actually how I view it now. So you can, yeah, you can say once I learned cellular automata, it changed my view about Go. Yes, indeed. So since I learned cellular automata, the Go game becomes boring. It's of no interest whatsoever. But I'm still interested in it though. But it changed my view. Like from theoretical point of view, the Go game has no interest whatsoever. It's just another cellular automata. Uh, as opposed to before, I would think Go game is like this unique and very somehow it captures your intelligence, because you have to because it's far more complex than chess, computer, than the chess. But after I understand cellular automata, my view changed. So so what I want to show you, pretty math books, math notes. Okay, so there is the. Okay, so let's go here. Uh, okay, this is Wolfram language. Okay, let me show you. I wrote this in 2000. In 2000, in 1997, I wrote this notebook. In 1997, this is doing tiding theory, symmetry, group theory. So so this is my opportunity to show it. That is all. Okay, so but I want to show you something else. Um, and all these are math things. This is a plot of sine cosine stuff, combination of sine cosine. All these are done in Mathematica. This kind of plot is called density plot. So you have a function of two variables, right? So you put two numbers to a function, it comes out a number. So you can plot. Usually it shows like a 3D surface. But instead of a surface, you can think, you take the output and you just plot it as a dot. The bigger the value, you plot it as white. If it's low, the value is low, you plot it black. So you have this kind of graph. Now this is called density plot. In Mathematica, they call it density plot. So all these are plots of function of two variables that returns one value. Okay, so all these are plots of that. I did this in 1990. All these are 1997 or so. I put on the web in I think maybe I did it in 2004 maybe. Um, but well, the core is probably 1990s. But anyways, then you also have these kind of things. You can do this. This is a, for example, this picture. I don't know if you. This picture is a hexagonal grid. Okay, a hexagonal grid. Then you rotate it. The more close it is to the center, you rotate less. So the further away you rotate more, then you get these. Okay, that's how you do it. So, but how do you code this? Well, you need matrix multiplication. You need a function. You need to create this function. You need to. This is when you need to know math. Okay, you need to write a function such that it does rotation, but the further away from a center, it does more rotation. So it's a matrix basically. It's a matrix. Then you have this, for example. This is a. It's a. In the beginning, it's a grid of stars arranged in a particular way. Then you apply a transformation, so it becomes this wave thing. And all these are matrix. All these are basically, basically you have to find the function. What is a function such that it maps a point in the plane, such that it comes out like you have this wave effect. And today, many of these you can do in, for example, in Photoshop, and this fisheye lens in Photoshop, in GIMP. People have studied this, and they probably build in. You just pick, I want fish lens, I want wave effect, probably. But at the core, it's a function. Um, yeah. So that's these. But what I wanted to show is the cellular automata example. Okay. So anyway, all these are math plots. Okay. I want to show an example of cellular automata. Uh, there it is. Okay. it's viewing image. Okay, so that's one example of cellular automata from his book, New Kind of Science. So you begin at the top. You just have one. So what is this? These are actually grids. So imagine it's a rectangular grid, lots of rectangular grid. Now each cell, each rectangle can be colored either white or black. You begin at the first row, okay? First row, you can color some of them black or white. Now on the second row, it generates a new coloring depends on whether you have rules like if a cell whose neighbors are black, then the next generation is gonna become white, let's say, for example. So you have several of these rules. Each cell depends on your neighbor. If your neighbor is black, on the left, black on the right, and then it becomes some color. So then you have other rules, like if both are white, then what color it becomes. So that's a rule. So you begin at the first row. You can randomly, make some cell black. Then you follow this row, you get a new row. Then follow it again, you get a new row. Then repeat. Then you get a picture. So based on what rules you begin with, you have a this kind of pattern. And it turns out for certain rules, the pattern becomes unpredictable. That is random. Now, random is a very extremely complex idea because you cannot actually define it. Well, you can. Mathematician can define it. Like to us, each one we think, oh, random is so easy. You just throw a dice. But you need to define it. How do you define the concept random mathematically? It turns out it's extremely hard. So by the time it's extremely hard. There's no way you can do it by statistics, but that's one random in one way, but not in another way. So by the time you actually need to, by the time you understand how difficult it is, why all this definition doesn't work, that's equivalent to like a PhD in math, kind of, or masters, let's say. So yeah, and by the time today they have a definition for random, a mathematical definition. I read it. I don't quite understand it, but I know what level it is. Basically, like PhD in formal logic, something like that. In foundation of math or computer science, you could say that. Yeah, the formal mathematical definition of random. But anyway, so it turns out cellular automata for several certain rules, it is random, and you have this pattern, and you can use it to generate random numbers. Random numbers is one of the big topic. People need. Before I don't understand what do you mean? Why is it so critical? I mean, you just throw a dice. Well, the thing is, you can actually throw a dice, but then so it's rather hard to generate random numbers. And then why can't you just use electronics, something? But it's hard because first of all, scientists, mathematicians struggled for decades to define random. They cannot define it. So if you cannot define it algorithmically, I mean, you cannot define it, then that means you cannot have a test of something that is random. You cannot test whether you don't know if it's random or not. I can throw a dice, but how do you know? So I throw a dice, I come out a bunch of numbers, let's say 1 million. But how do you know my dice is not biased, right? So you have to have certain test. Then okay, this is probably not random. Even though, I told you, look, I just bought a dice, I throw it. To most people, that's random. But then if you, need this number for something, you can tell that the dice is biased because let's say the number one happens too much. So anyway, so random numbers, so it turns out that this can generate random numbers. That's an example of cellular automata. Okay. Then let's go back to about the book. So we were talking about the book. What is this book about? So this book about, so the 12 chapters plus notes. The notes part, the notes section is about it's like a survey, an overview of the history of math and computation, and also aspect of that about physics. Okay, logic, logic, math, a survey. So just for the second part, just for this part, is worth it. You just read this part, notes. It's a survey of the, history of math and computing. Then what comes in front is 12 chapters. Now, among the 12 chapters, the first chapter is actually about cellular automata. It's about all these kind of cellular automata. Okay, there are several types. For example, this one is two-dimensional. Actually, this one is one-dimensional. This particular one we just showed, it's a one-dimensional cellular automata because you begin with a row. Okay. Now the game of life, this Conway's game of life, this is an example of two-dimensional cellular automata. You begin with in a plane. Okay. Then you can have three-dimensional cellular automata. Okay, he talked about the book. One of the chapter is about three-dimensional cellular automata. So chapter 1 to 7 is about cellular automata. It's all about cellular. It's all about cellular automata. Okay. Now chapter 8 to like around chapter 8 to 12, it's about applications or consequences of what he found about cellular automata, how it applies to physics, cosmology, biology, foundations of math. Okay, in his point of view. Okay, that's an introduction. That's what this book is about. Okay, that's a content of this book. I would say it's worth reading. I enjoyed it very much. But let me now this book is he is a megalomaniac. Okay, he's a narcissist. So every page, it's literally okay. Every 5 pages, every 10 pages, he will he will remind you in various ways. I'm the greatest scientist. Okay, I'm the greatest genius in the history of humanity. Very annoying. You read it, like I already know that this is the 100th times you said it, and also every page he will repeat. He will repeat that there's a something about the new kind of science. This dramatic title. He will say uh, simple programs generates unpredictable patterns. Okay, he will repeat that concept every 5 pages. Sometimes literal repetition every 5 pages, and this is got 12,000 pages. So it's extremely painful. Very, you get pissed reading this. You after after reading 100 pages, you get pissed because every 5 pages he tells you again. Oh, by the way, simple programs generates random behavior, and then next 5 page, oh, random behavior can be generated by simple programs. He does that. And of course, people in general, the scientists, the academics, professors, they don't like him. They attack him. Like they publish. This is pure garbage, no content. They are they. It's by the way. So those kind of criticism, there are a lot. There's this guy who collected all the criticisms of Stefan Wolfram's book, published in physics journal, math journals, logics journal. A lot of people attack him. Some will say this whole book is like nothing. There's nothing new. Everything he said is already studied by someone else. He just like pretend it's his invention, and lots of things like that. Most of them are false. my that's my opinion. Their criticism, a lot of them are false. They do that only because they don't like him. But of course, part of it is very solid because he does, repeat, I'm a genius, like implied, like every few pages. He's very, very extremely annoying. Uh, you know, I know so much about this book because I read it, like 2 or 3 times, and from different years. You can call me a Stefan Wolfram fan. I like his stuff. I usually often agree with his stuff, and the fact that he's a megalomaniac, I can understand. I also find it annoying, but I accept it. You know that's you know that comes with him. Anyway, so yeah, on Amazon, there are like thousands reviews. When the book came out in 2002, there are thousands of reviews. I read every single one of them, and I read every criticism of book of this book in journals, in physics journals, and I think there's also one from New York Times, and there is a guy who collected all criticisms. Let me show you where. Okay, this mathematician, this Edwin Clark. Okay, Edwin Clark. Whenever there's a new criticism of the book, he collects it. This is old. This began in 2002 or three. Okay, so this I read them all. Anyway, so that's about this book. So I like it. Okay, so if you like it, buy it. Um, let me post my link. Okay, so if you buy it from my website, from my link. So let's go back to the comments. Oh my God, no comments, guys. Okay, I think we are about done then. About parsing HTML in ELISP, I like to do right. I like to write that, but I have not done so. I might do it in Golang, but actually there's a program I let me just read the comments, okay? Uh, so panel says, am I still going? 12 people. Okay, yeah. Okay, so oh my God, we are about to end. That's 80 minutes. So um, panel says, how do you source highlight your code boxes in HTML page? What do you mean source highlight your code boxes? Oh, you mean syntax coloring? Yeah. So for example, let's go to Python. Show. Let's go to Python 3 basics. Like that. You mean this coloring, right? So panels answer. I like comments, guys. So Emma answer if you are still there. Cool graphics, great, more magic eye stuff. Okay. Nick says the only thing that's not unpredictable is that he's the greatest scientist ever. Okay. Dan says megalomaniac is an understatement. He's unbearable, extremely intelligent, no question about it, but extremely off-putting. Yes, that is true. That is true, especially well, mostly in this book. But today, you don't see that as much, though. I mean, this book in particular is like that. But today, you read his blogs. He's still kind of, very, arrogant, but n- not as off-putting though. You can still, you can still read it. So yeah, so syntax highlighting. How do I do that? It's actually very easy. Actually, I have an article on that with full detail. For example, let me show you an example. First of all, let's say building help. No, And okay, so let's say this simple code. Okay, Python print version. Uh, it's open in Emacs. So you skip around, you can see here's the code. Okay, here. Okay, so let me do this. Close, close. So let's go to. Let's just do a Python. Okay, it's all. If you use, excuse me, if you use XAR HTML mod, you can do it. So I call a command. Look at the left window. You see my command. So I call it. Then Python 3. Enter. I got a template. Then I move it to a buffer. Okay, then I can start to type. Let's say x equals to array 3, 4, 5. Okay. Oh god, I forgot my Python. Let's say print x. Okay, run it. Works. Okay, yeah, that's Python. Works. Now delete this file and copy it. Paste it here. You see it's there. So show in browser. Go down. It's here, but it's not colored. So I want to color it now. Now look at the left window. I call the command. Now it's colored. You see those span tags. Now in browser, refresh. You see it's colored. So this works in Emacs Lisp too. For example, let's create a new Emacs Lisp. Okay, then go to here, define, return. Let's say XX. So let's just say message, hello. Okay, okay. So that's the code. Copy it, delete that file, paste it here, color it. Oh, whoops, press the wrong key. Color it. Okay, save. Go to browser, refresh. There it is, colored. Firefox has a bug because every time you refresh, oh, it doesn't happen here, but sometimes when you refresh, it scrolls. This began about half a year ago. So how do you do it? Actually, so I have an explanation, full detailed instruction on how to do that. So if you have to go to my Emacs Lisp blog, practical Emacs Lisp, no, command examples, yes. Then search for syntax, wait, SYNT, okay, not there. Search for color, color source code, there it is, color source code. So here are a collection of HTML commands. So this article is very old. This began in 2007 because back then at that time I need to do it. So it's now I've been doing that for 12 years. So I show you the detail exactly how to do it. You know how do you write a code and but if you just want to use it out of the box, use XAR HTML mod. It's on GitHub. Just search XAR HTML mod. Okay, so that's it for today. Thank you guys for watching. That's it for today. Anything else? So let's see. One minute to type your comments. Okay, then I click exit. So today, so there's another question about Emacs Lisp. Writing a HTML parser. That's something I want to do because I write HTML all the time. I don't have a validator right now. It used to be on Firefox. There is a validator. You used to. So whenever it's invalid, you'll see some kind of a red sign. But okay, tomorrow HTML and Emacs Lisp. Yeah, okay, that's a good topic. So tomorrow I can do a introduction on XAR HTML mod, because I haven't done that. I think that's it might be interesting. Some people I know are interested in that. XHTML mod. Where is it? Uh, General. Okay, so I put it in here, alpha, because actually I've been using this for 7 years now. But nobody else use it because it's pretty good. Okay, so anyway, I so tomorrow we can talk about this. Like I can do a introduction on these features, package features. Um, yeah, okay. So that about HTML parser, there's something we can talk about tomorrow. I need a parser. So it used to be a Firefox. You have a button. Yeah, you can install a plugin. Then whenever a page is invalid, pure, strictly invalid, like invalid HTML, the button will become red. But that stopped working several years ago, 5 or 7 years ago. What you want actually, the important thing is that you want a local validator. You don't want something that go to, for example, there's a HTML validate data official website from W3C. Now it can, anyway, you don't want a tool that goes there because most of the time your file is local. Usually they require you the input to be a website. So that's one of the issue. The other issue is that you don't want to go remote, go to a server. You want just a local validator. So so I've been searching for that for a long time, and still there's no solution. I don't have a solution now. So I've been thinking of writing one myself. The full validator, if you want a validator that's a full validator, meaning that it according to the HTML spec, which is extremely complicated. Okay, if you can write that, you will be one of the great top programmers. Nobody can do that. A few people. So, but what I really want is not that. So, what I really want is just a simple um, well-formedness checker, something like that. All I need to check is whether all the I have all the ending brackets. We don't have missing tags, things like that. That's all I want. I don't want the 100% full parser. In fact, I don't want that even because the full parser, especially HTML5, you can omit many tags. For example, something. Okay, something. Some you can omit the closing paragraph tag. For example, if such and such that the next tag is something, or under certain conditions, then you can also omit some others, things like that. Very complex, idiotic. Okay, what I don't want that. I want the tags to be always opened and closed. And also for certain tags, for example, image tags, there's no close tag, but you can add a slash as a XML syntax. So I want to write that, maybe write in Emac list, or I've been thinking Golang. And it's not too difficult to do because I have a program that validates parentheses. Like you check all sort of parentheses, parentheses, square brackets, curly braces. You can check, a thousand pages to see if there's mismatched parentheses. So once you know how to write that, that is pretty simple. Then you can write a, this formedness checker for HTML or XML, because all you're checking is the matching of the tags. Anyway, maybe we talk about that tomorrow. So so thank you guys for watching. Bye.